Hello, this is Mr. Stansbury. I'm going to take you through the notes on normals. At the end of this, you should be able to say, I can find the equation of a normal to a graph at a given point. So first off, what is a normal? A normal to a curve is a line which is perpendicular to the tangent at the point of contact, which we call the point of tangency. So, for example, if the yellow here is our function f of x, this red spot point right in here, that is our tangent point. So here's our tangent line. What a normal line is actually there's the tangent point, and it actually makes a 90-degree angle with the tangent line, and that's the normal line. Okay? So let's take a look at an example. Example 3, find the equation of the normal to this equation here at the point where x equals 1. So just like on finding the equations of the tangent lines, we have the same exact needs. Well, just a little bit different on the needs. Again, let's do that. Let me do that in a different color so it's easy to figure out what we have found. So here's what we need. We need a y. Oops, let's start with x. That makes more sense. An x1 officially, a y1. And we also need a slope. Okay, but now this is a perpendicular slope, so that's why it's a little bit different. Okay, so that's our perpendicular slope, which is going to end up being our m value in y minus y1 equals m times x minus x1, our point slope formula. Okay, so let's do this. So we need the x. They give us the x. X equals x sub 1. Our x value right here is going to be 1. Okay, to find the y, whenever we want to find the y, always plug it into the original equation. So f of 1 equals negative 1 squared plus 4 times 1 plus 1. Just plug in 1 in for these x's here. So f of 1 equals 1 squared is 1, and then we got the negative of that. 4 times 1 is 4 plus 1, so that gives us f of 1, which is really, instead of f of 1, let's just write this. This is our y, right? Y equals 4. So our y1 here is 4. So now we have y minus 4 equals, and then we have x minus 1. Now all we have to do is figure out the slope. But it's not just any old slope, it's the perpendicular slope. But we still find our slope the same way, and that is find the derivative of our function. So f prime of x is going to equal 2 times negative 1 is negative 2. Subtract 1, that's negative 2x. 1 times 4 is 4. Then we subtract the 1, so the x's are gone. And then also the derivative of a constant is always 0. All right, so here's our derivative. Now we plug this 1 in for our x here in this derivative, and that will tell us what the tangent slope is. And then we have to find the perpendicular to that. So f prime of 1 equals negative 2 times 1 plus 4. So that's simply negative 2 plus 4, which gives us 2. So our slope of the tangent equals 2. Okay? Now, to find a perpendicular. So if our slope, our regular slope is 2, let's put that as 2 over 1, then our perpendicular slope, which is signified by upside down capital T, because that makes a little perpendicular line there. What we got to do with this is we have to find, officially, mathematically, we call it the inverse reciprocal. But what I like to say is we're going to flip and switch. Flip and switch. Okay, we're going to flip this over. That's the reciprocal. And then we're going to switch the sign. So right now it is positive 2 over 1. So if we flip that over, that turns into 1 over 2. Since it was positive, it is now negative. This is going to be our perpendicular slope, negative 1/2. So we put a negative 1/2 in here, and then we solve this, and there's the equation of our normal. Okay, so we get y minus 4 equals negative 1/2 x. Negative times a negative is positive 1/2. And then we add 4 to both sides. So we get y equals negative 1/2 x plus 4 and a half will be the equation of our normal. Okay, so that's how we do that. Again, pretty much the same thing as a tangent line, except for you just have to find the perpendicular slope, and then away we go. Okay, one more example number 4, but before we do that, let's take a quick comedy break.
So much the number, man, it's I feel old. Some things happen to make me feel old. For example, I read an article not too long ago. Society says the average man at 27 should be married. It's very depressing. So I don't think society factors in things like maybe me and a wife at this point in my life can come together and fit in my mom's basement, because it's not that big. It's finished, but it's damp. She ain't gonna want to do it.
All right. Find the point where the normal to y equals x cubed minus 4x squared plus x plus 3 at 2, -3 meets the curve again. So back to our little need list. We need our x. We need our y. Oops. And we need our perpendicular slope. So look at this. They actually give us the x and the y, so they kind of save us a step here. 2 negative. Oh, let's put that back in blue because that's new stuff that we found, right? So we've got 2 and we got -3. Now we just got to find the perpendicular slope, right? So to find the perpendicular, we got to take the derivative, right? 3. So y prime is going to be 3x. 3 minus 1 is squared. 2 times -4 is -8, x to the first, and that's x to the first. 1 times 1 is 1. Subtract 1, the x's are gone, and then the 3 is gone. So there's our, sorry, this is our derivative, right? So to find the slope at x equals 2, we got to plug the 2 in there, right? And so this will give us the slope of the tangent, and then we're gonna have to change it to find the slope of the normal, right? So slope of tangent is gonna be 3 times 2 squared minus 8 times 2 plus 1. So we get 2 squared is 4 times 3 is 12 minus 16 plus 1. So that's 13 minus 16. Gives us -3. So that's the slope of the tangent. So to find the slope of the normal, we have to do the flip and switch, right? So -3. Oops. That's not 3. That's a 3. -3 over 1. To turn it into the perpendicular, we have to flip it and switch it, right? So the 1 goes on the top, the 3 goes on the bottom. It was negative. It's now positive. This is our slope, 1/3. So then we're going to plug that into our y minus y1 equals m times x minus x1, right? And so we got y minus -3 equals m, which is 1/3 times x minus 2. Not going to be pretty, but it's going to work. Y plus 3 equals 1/3 x minus 2/3. Right, and then we simply subtract 3 from both sides, and we get y equals 1/3 x minus 3 and 2/3. That is the equation of the normal. And then it also says, and find the point where the normal to this at 2, -3 meets the curve again. So that's just the equation. So now we use that equation, plug it into our graphing calculator, or plug it into Desmos, and we do y equals. We're going to clear these things out. Come on, go away. There we go. And we're going to put in our 2 equations. Doesn't matter which one goes first. I usually like to use the regular, the one that we were given. X cubed minus 4x squared plus x plus 3. Right? And then in the other equation, 1/3 x minus 3 and 2/3. So 1/3 x minus 3 and 2/3. Let's do this. 3 times 3 is 9, plus 2 is 11. So minus 11/3. And we graph that thing, and again, cross our fingers, hope that this line here is the tangent right at 2. So there's 2, -3. So there should be a line cruising right through here. Oh, but this is our normal curve, right? So there's our tangent line, and there's our normal. That looks pretty good. It looks a little, I don't know, if I'm drawing a tangent, I'm probably drawing it like that. So it looks a smidge off, but I'm feeling pretty decent about it. Okay, so to find where it meets, where the perpendicular meets again, is actually 2 different points here, isn't it? It's here and it's here. So let's find both of those. So second trace, and we're going to find the intersection. Oops. And it's given us this point here. Now, what I want to do is I want to move it close to, but I don't like to put it right on top of, but close to the first spot I want to find. So first curve, yes. Second curve, yep. Guess, sure. So another place that it meets is negative 1.08 and negative 4.03. All right, so there's one intersection point, and it meets at another point here too, right? So it also meets over here. So second trace, and we find 5. And now I'm just going to scroll this thing over. So now I'm closer to this intersection point. Because if I do it right here, it's going to find this intersection point, which we already know is at 2, -3. We want to find this other one, so I usually like to try to move it a little bit past. Because I'm pretty sure there's no, well, I'm sure there's no other intersection points over here. So first curve, enter, second curve, enter, guess, yes. And it gives us 3.08 and negative 2.64. And those are our 2 other spots. So this really should say points where the normal meets the curve again. So it actually meets in 2 other spots there. Okay? All right, that's all we have for the normals. Notes, if you have any further questions, please feel free to ask. Thanks.